Hi, this is DA5030.Deshmukh, and today I'm giving my presentation on Introduction to Data Mining and Machine Learning. My project title is Black Friday Sales, and this is actually me. I'm sorry I'm not able to cast myself on the screen, but there's some technical error. I'm trying to figure it out. So, to start with, my title for the project is Black Friday Sales, and here the aim for the project is to evaluate the purchase of the people shopping on Black Friday sales and also to target specific customers on that day so that the revenue can be increased. I acquired my data set from Kaggle and it has almost 12, it has almost 12 variables, more than 500,000 observations, and the variables they differ from user ID, purchase, product category, different. So after I acquired data, I did my data exploration. Here you can see that this 25% of the male and 75% female. Similarly goes with single and married people, and the data it is almost normally distributed. For the outliers, I used Cook's distance method. Uh, Surely there are some extreme values in the data set, but we need to consider that there are the target as much as people, because during Black Friday sales you do tend to shop more. So yeah, after cleaning, where for cleaning for data imputation, to find out NA values, I use mice package, which shows me exactly where my data is missing, which is called product category 2 and 3. The feature engineering part was done, where two features like user purchase count and product sold count was introduced. Later I did my PCA, which showed the variation of the data was almost more, and then it decreased afterwards. The correlation analysis uh, is shows up to 0.32, which is between the range of 0.2 and 0.4. So that's a good thing. If the correlation is less than that, then it's a weak model, and if it's more than that, then it's really considered as really strong. After feature engineering, I went up to my dummy codes because I had some categorical data in my data set. For normalization, the reason I use normalization is because the purchase column has values as less as 187 and as maximum as 20,000. So that type of fluctuation would actually screw up with my results. So that's why I normalize my data. So I constructed basically three models, which is first one is multiple linear regression, and here I want to say that I actually took 5,000 for my training and almost 5,000 for my testing data. The reason is because here the data is almost 500,000 and I'm not able to process all of that data. The system crashes and it doesn't move forward. So for that I used only 5,000 in training and 5,000 in testing. Here you can see that it's multiple regression model. It fits. The difference between these two models is that like this is my first model, and then I was trying to tune it up and try to improve its performance. It actually something I read in the book. It's the additional beta that will estimate for tuning and which is intended to capture the effect of the x squared term. This allows the impact of purchase to be measured as a function of like purchase squared. To actually increase your accuracy and gives you a good model. Afterwards I use decision tree. So decision tree are really useful for predictions for categorical variables. We feed the data for the prediction from the training data set. The model was able to predict. The accuracy was uh, like it was good. And then afterwards we also found out that there are 24% of the married people who are shopping, and more people are shopping who are belong to who are belonging to actually single data. So most of the people who are shopping more are single people. So after creating these two models, this so after this I went forward with my neural network, and which is giving me the accuracy of almost like 21%. The correlate. This is my shiny dashboard, and this might not be able to work because the data set is too large. So as I said previously, the data set here is more than 500,000, and because of this reason, the R shiny is not actually able to work properly. So the models that I use, as I told you before, that they are linear regression, decision tree, and neural networks. The accuracy for all three models are 33%, 70%, and 21%. The reason linear regression is less because the data set that we use, like for the training and the testing, we use only 5,000 of like data points. It could go up, and this could improve significantly if we use the entire data set, uh, because most of the purchase data is almost linear. So the conclusion with this project is that the linear regression model works best when the data set when the data set is more, and we need more data on purchase, user purchase, and product patterns, which are directly proportional to each other. So if we have more data on this, the linear regression would the value would go up. The data set might work differently with the entire data for like over 5 million, sorry, 500,000, and might even be more accurate and might even give more accurate predictions. Thus, the models that are generated in the project are not really up to the mark, as the entire dataset can't be processed in the R, and in my system, as the dataset is large enough to max out my vector space. So I received a lot of errors while processing the data. It was saying that your vector space is almost out, so you have to give more space. Thus, the further processing is not possible to move on with the entire data set and to give the accurate predictions for this project. The future scope for the data can be done with working with the different programming tool like Python, which have different functions like pandas and numpy that will be able to process the entire chunk of data and give valuable predictions. This is my knitted file, and as you can see the PCA data over here. Sorry, the PCA graph. Decision tree gives huge amounts of calculation, and that is actually really long. So I'm considering that most of the pages are like that only. So that's it. So this is my presentation for data mining and machine learning subject. Thank you so much. It's been a really great experience, and I would thank my professor Martin and all of the DAs of DA5030. So thank you so much.